Hey, what's up guys? In today's video, we're gonna look at another example from the Maui.graphics library. In this case, I threw together a little quick example of two types of drawn kind of graphical view controls that you can do, just really to give you some inspiration as to what you can do with the graphics library in your own apps. These two ideas came from a user who left a comment on my last video, actually right here. Yeah. And yeah, so I thought, that'd be a cool challenge to tackle. So over the weekend, I threw together some code to do that. And this is what came out of it. So let's take a look. Okay, so these are the two drawables I threw together. This is I guess I'll call it a linear meter and a radial gauge. This is just two things I threw together, like I said, based on that comment. And, they're not perfect. They could definitely be spruced up a bit. It's something I did in a couple hours. So, with some more effort, you could make it a little more fancier, but the main thing I wanted to show was how to kind of take these shapes, manipulate them to get the look you want, and then also get them to respond to input, through whatever quote API that you've written. In my case, I'm setting this value called a fill value, which tells the drawable how to draw it, and then it gets redrawn every, few seconds or whatever. So I got this button down here. It says don't touch this button, but we're gonna be bad boys and touch it. So if I touch it, you can see that, oh, the meter fills up a little bit. And actually what's going on here is I've set the meter to drain constantly. So if I touch the button, it adds 10 to the meter and then it drains. But basically this is how, showing how you can respond to input from touch the button. And you can see that, the meter fills up, it comes back down as it drains, and the radial needle moves along this area, which the math for that is much harder than you would think, but we'll dig into that. So yeah, this is just, two little drawables. There's some cool stuff about these that you can't really see here, in that they're responsive to how you design your views, things like that. So I'll show that in a moment. But yeah, these are the two drawables that I've just threw together. Obviously, like I said, you could do some more UI work to them, make them look a little prettier, but so let's dig into the code on these. Okay, so I made my emulator a little smaller because it was much too big. So let's look at the actual XAML for this real fast. So this is just a one-page little demo app. And I'll also say that all the code for this is in my GitHub repository that's down below in the description. So if you want to see this for yourself, you don't have to type all this out or anything. It's all out there. You can have it for free. Go for it. So this is the XAML for this. Zoom in a little bit. So yeah, basically, as discussed last video, all of these drawables use this graphics view, and then you attach the drawable to it through this drawable parameter, and those are related back to this code and specifically this draw method that's used to draw the object. And it redraws over and over again, basically, and that's how you get motion and animation, is it redraws itself with different things. It responds to some number or something you give it, and it redraws itself with that number, and it does this over and over again. So this first drawable here, this is the meter drawable, which is this top, linear meter. And yeah, it's pretty basic. I just threw this together. I will say the way I design these drawables is to basically fill up their entire graphics view area. And the reason for that is because then you can manipulate the graphics view area how you want, and which would change the size of the drawable itself, and it's kind of responsive in that way. Though that does actually create an issue we'll talk about in a second. So this is the meter drawable. This is the radial gauge. It's, pretty basic. If I for instance, change this column to 2, you can see it responded by making it much smaller. This would actually be better if we were looking at the Windows one, so I could resize it and such. But then if I set this back to, say, column 1, it kind of splits the difference. It's taking up 2 columns. It's a little cut off just because of how I've got the grid set up. Then if I change it back, it responds by adjusting back. You can do the same thing with the rows. You can whatever. So basically the idea here, the reason I made the drawable basically take up the whole graphical view was so that you can manipulate the graphical view and then manipulate the drawable size. So it's responsive in that way. Though I will say I do need to do a little work on the radial view. For instance, you can see it's a little small here, but you can see the top number is cut off. There should be I believe a 49, one of those numbers right here, but it's actually cut off because it's pushing up against that top view. So to fix that, all you need to do is basically adjust the drawable down by a few pixels. So it's not too difficult, but it would take some playing around. Again, these aren't perfect, but this is kind of an example of how I would do this you'd put in a little more work to get them to look even better. But yeah. So anyways, so that's the XAML part of this. It's pretty standard. I mean, it's basically what we talked about last time. Let's actually dig into the code behind. I'll show you how I'm doing the draining and that kind of stuff. So, again, I'm using a timer. Timers are really good for this type of thing because drawables are static objects that get redrawn. You want them redrawn over and over to kind of create this animation, right? I click the button, the meter fills up, and then I let it go and it drains. That is because it's actually redrawing itself over and over and over again really fast. This timer is a timer of 50 milliseconds, so very fast, 0.05 seconds. Then every time it elapses, we call this drain meter function method. And yeah, it's doing what you might think. I'm grabbing the graphical view and the meter drawable. I'm setting this value in the meter drawable. We'll talk about that in a moment. And then I'm looking at this fill value. And as long as it's not 0, then we're going to subtract 1 from it and call the graphical view .invalidate method, which again from the last video basically tells the graphical view to redraw its drawable object. So then I'm doing the same thing with the radial gauge, exact same thing. I'm saying a gauge thickness. We'll talk about that in a moment. And then yeah, exact same thing. If it's not 0, we're going to subtract 1 and redraw. Cool. The don't touch this button, that is a method that's just called when you touch the button. And all it does is it grabs the same view in Drawable and then it adds 10 to them. Pretty basic. And then tells it to redraw itself. So the code behind, very basic. So yeah, up here in the constructors where you would set all these settings, I got a horizontal mode, a gradient fill, which we'll talk about, the steps of how the drawable, let me make this bigger, how the drawable steps across in its scale. So this can be modified too. It's at 12. So right now, basically what it does is it takes the max value, divides it by that number, and then that's how each step gets set. And then there's a base tick size, it shows series, which is true, which is just saying show the numbers. And then there's various different things, max value, all this stuff. So that's the code behind for the example. Now let's actually dig into the actual drawables themselves so I can show you how I did some of this stuff. Okay, so let's look at the drawables real quick. I'd originally intended to do like a base drawable with some values, but then I just said, I think it's obvious enough what you can do with that. So I'm not going to bother with just 2 drawables. If I were doing a lot of different types of drawables like these, I would probably move some of the properties and such into a base drawable class so that you can inherit that class. For instance, max value, fill value, things that both of these share, I would move up into the base. But anyways, so yeah, let's start with the meter drawable. Yeah, there's a bunch of different properties. You can set the color of the meter itself, which is the actual outline here. So if you had a white background, you would want to set it to black. If you have a black background, maybe set it to white, that kind of thing. There's also a fillable color, which is red, but actually we're not using that at the moment because we're using the gradient color. You can see it goes from green to red over time, and I'll show you how I'm doing that. There's a max value, there's steps, there's base tick size, rounded radius. Oh, this is a rounded rectangle. So the corners are rounded, and rounded radius basically tells it how much to round the corners. There's a fill value, which is it corresponds to the actual amount that this colored area is filled. That's what's getting drained. Gradient fill, which is going to be true. I said it's true in there, and then show series, which also says true, which shows the numbers. So as discussed before, the straw method is where everything happens basically. So, we set meter color, we set a stroke size. I will note, I was trying really hard to get this blend mode to work, and for some reason it wasn't. And I don't know if it's my understanding of what blend mode is or if there's a bug. But basically the point I was trying to do with this line was, well, when the meter fills up, you can see like the tick marks are on this side of the fill bar, and that's what we want. Which I figured out how to do it later, but the blend mode I think should cause it to do this naturally, but I couldn't get it to work. The fill bar was just filling up and covering up the tick marks and actually the outside of the meter. So yeah, I don't know if this is just not doing what I think it should be doing or what, but I tried all kinds of different blend modes. None of them work. I'll put the docs for blend mode in the description. You can read them yourselves. Maybe I'm not understanding them, but I'm pretty sure that if 2 things are drawn over top of each other, this should impact their behavior. And in my case, I wanted the thing being drawn in to be behind the thing that was drawn already there. So yeah, we're using the dirty rect, which is the rectangle that gets passed in. That's basically the graphical view area. And we're using that to do most of the calculations. So yeah, we got this horizontal view. There's all kinds of code in here that's specific to just getting it to look the way I want. This is where I'm keeping the fill value inside of the max value range between 0 and max value, because otherwise it would just draw negative forever. And yeah, we're calling this fill meter, and that does this. So we determine a %, We, have to do certain things based on horizontal mode, etc. And yeah, we're basically just, we've got this rectangle here, and the fill percent is how much of that we want to fill with the colored rectangle on the inside when we draw it. Makes sense. This right here is the gradient color. So if someone has determined they want to gradient fill it, like we're doing here, you use what's called a linear gradient paint object. If you want a linear gradient, there's other ones as well. And it has some properties that we set. So start color is either going to be green or red, depending on if we're in horizontal mode or not. In color, same thing, but opposite, red or green. So basically it's saying start with green, end with red, and the start point is 0, 0, which is just basically, I guess that would be up here. So we're kind of doing the opposite. So yeah, if horizontal mode is true, we go red, else we go green. So end color is green in a vertical mode, and 0, 0 is up top. So one thing to note about graphical views is they start in the top left corner at 0, 0 of their view. And the bottom right corner, for instance, to get that is dirty rect.width, dirty rect.height. So that's the kind of range you're working with there. So yeah, I mean, technically I could flip this backwards and it would be the same thing, but anyways. So yeah, that's how the linear gradient paint works. You basically tell it a start point and an end point, and the start color and end color, and then it gradiates over those colors. Kind of nice. And then you do the set fill paint. And if we're not using gradient fill, we just set the fill color to be the color that the fill color is. And then we fill rounded rectangle, just like the outside, except this time we're doing the inside. So that's the fill meter. Let's see, there's two others. There's the actual draw meter itself, which is pretty basic. It's literally just doing the math to draw this. And then the add tick marks, which is, one of the trickier things. Basically, we go and we walk, I think actually down this line here, which we determine based on the stuff sent in. And we draw a tick mark with a tick size, and we're doing draw a line at where the starting point of the next line is to the offset of it based on tick size. So we're saying, okay, we've determined we need a point right here, and then we're going to draw to the right through next line dot offset, which is a pretty useful method when you're doing this stuff. Point dot offset is literally just where the next line point is, get its offset certain X or Y coordinates away. In our case, we want the same. Vertical mode, we have the next line here, and then we want the X coordinates to be tick size to the right. And the reason I'm using tick size variable is we set it based on how many steps we're in the process. That's how we get these different size ticks, right? And so yeah, you probably understand that logic of just looping through there. And if we're showing the series, the text, then we also do a draw string method, which will write out the numbers themselves. We're doing the percent of max to string, and we're doing it horizontal alignment center, string point.x, string point.y. String point is determined by, again, another offset, and this time we're going the other direction. So in vertical mode, we're doing next line.offset -10. So we're going 10 to the left. So yeah, that's how you draw the ticks. That's probably a little too fast for you to fully understand that code. So I would definitely recommend looking at it on the repo and taking it and doing what you want with it. And yeah, that's the linear meter that I'm calling it. It's really basic. You can resize it all you want. It doesn't have to be this exact shape. You could change the colors, you could change whatever. It's fairly customizable, and that's kind of the point with these, is to make them customizable such that depending on the type of look you want to get in the app you're making, you can change it. That one's pretty easy. Now let's talk about the radial gauge, which was much harder. But let's talk exactly about how I did it. All right, so this radial gauge drawable. Yeah, this code, a little more complex. There's a little more math involved, and you can see why. I mean, if you look at the gauge itself, you can probably determine how it's created. We got a couple circles. We have some way to remove this part of the circle, which I'll talk about that. And then we have a needle in the middle, which is a line. In the last video, we looked at a clock, which, this is a similar thing of drawing a line in a specific position based on some data, specific angle in the circle it's in. And this is the same thing, except the math is a little more complex. So let's dig into that. We're setting stroke size, stroke color, fill color, all this stuff. I have a thing called a limiting dim. And what that is basically we need to know which of the dirty rect.width or the dirty rect.height is bigger or smaller technically. And whichever one is smaller, we need to basically calculate that as the limiting dimension of our graphical view. That way, if you shrink the graphical view widthwise, the drawable shrinks correctly, or height-wise, vice versa. We need to understand the limiting dimension in our graphical view, and then we also find the center of the circle, which I'm just doing very basic dirty rect.width divided by 2, height divided by 2. Gradient fill, very similar to the other meter. It's the same thing. I will say the start and end points are a little different. The start and end points are way out here and way out here. And so if you stretch this radial view too much, you may end up getting more of the gradient color in here for the entire thing, if that makes sense. So it'll just all be orange. You could fix that by changing these start points with some variables or something, however you want to set that, but just to note that. But yeah, this is done the exact same way as the other one. Okay, and then so as you can tell, there's some circles. So we have an outer circle, we have an inner circle, and somehow I've removed part of the circle. So yeah, those are pretty easy. Draw a circle, draw a circle. One is white, one is the actual lines of the circles themselves are black. The inner circle fill is white, and you can change that with a property set. But let's talk about how I removed this area. So this is kind of a tricky thing. There's this thing called a path in Maui.graphics. And basically what you do is you draw a path with these line to methods. So we're going to start our path and we're going to move to the center of the circle. Okay. Move to it's not part of the path. It's basically your starting point. And then if you do line to, you basically draw lines with the path however you want to. And I'm using a clip path method, which removes, or basically anything inside of the path is kept in the image. Anything outside of the path is removed. So what I'm doing is I'm starting at this center point. I'm going down this way to this corner, up, left, down, back up towards the center. And that removes this area of the circles we drew. And that's with this clip path function. I will mention that this clip path function is actually not supported on the Windows build path for .NET Maui. For whatever reason, the Windows side of things is very limited in image stuff. So clip path doesn't work. A few other things don't work. I figured this out because I kept trying to run it in the Windows version and it kept immediately throwing this really strange XAML breakpoint error. And then I finally figured it out. I believe they're working on implementing that, but just to note that if you try to run this line right here in Windows, it will break. So in Windows, what I would probably do instead of a clip path, I would reverse this. I would just do like this triangle here, and then I would like paint it your background color or something like that, so it's transparent, and that would remove this area. But yeah, so we're using clip path to remove everything that's outside of it, and that turns out is this triangle here. And also this triangle is very important because the sides of this triangle here become part of your calculation for the needle angle. So we'll see that in a second. That's how we're removing this part. So let's move down. All right, so we drew all the rest of these circles. And then here we're taking the top point of this path clearing triangle. We're taking the bottom left point, which is way down here, and the bottom right point, which is way down here. And I wrote this method called get angle degrees. Let's go to it real quick. So this is a formula that I saw online. I'm not going to admit to creating it. But basically it takes 3 points. It determines the angle of the center point based on the two vectors of, like it says here, P1 to P2. P1 to P3. Basically, you're looking at the angle of this area right here. So the way you get an angle of two vectors like that is with this inverse tangent function. So I put this math here to get the angle in radians, and then you do the math to get the angle in degrees, and then return the degrees. So that gives us the angle here. And what I've called that in this code is empty angle. It's the angle of the empty triangle. The reason we got that is we need to use this to determine the angle that the needle can move that's valid. So basically we don't want the needle to move anywhere in the empty angle area. So the way I did that here after struggling a lot with the math was 180 minus the empty angle divided by 2. So if you think about that, there's an invisible line here. The angle divided by 2 is here. So we're, if you didn't do the divide by 2, this needle would be straight down. So we need to adjust it by the divide by 2. And then we're divided by 360. And that gives us a percentage of how much of the angle to remove from the needle. So if you think about it, we have some math in here, right here, where the fill value for the needle for the radial gauge is from 0 to max value, right? But the easy way to do this to kind of adjust the math is to normalize that down to maybe -1 to 1, which is what I did. And that gives us this 0 POS. So this is a value between -1 and 1 that we will then adjust to make into an angle to put the needle there. So then we get the degrees of what that is. And then when we have this angle in degrees right here, it's actually from -360 to +360. And we want to adjust that down to essentially make it into our -100 to 100 number. So that's why we determined the remove circle percentage, so that we can then multiply the angle degrees by that percentage to reduce it down to our degrees that are valid. Hopefully that makes sense. It took a lot of thinking to figure that one out, but that's how I did it. So, and hopefully I will never write that code ever again. I'll just have it here. So I kind of got ahead of myself, but basically I just wanted to show what these were for. And then, you know, we have the fill values again, same thing. We're limiting the values. And then we do a draw needle, draw tick marks, and draw number display, which you actually can't see right now, but let's talk about that. So draw needle, like I said, basically we're doing all that math to determine the angle of the needle. And, you know, like I said, you wouldn't believe how long it took me to figure this out. And like I said, we normalize it, we get the angle in degrees, we reduce it down by a percentage. We then get that angle in radians because you need an angle in radians. And then we do kind of the same math we did on the clock from last video to determine the outside line point, basically. And we draw a line. So that's how we do the needle. Tick marks, very similar. We're doing the same kind of radial math. In fact, we even do the same remove circle percentage stuff because we need the exact same thing. We want to limit it to the outside circle and nowhere that's not valid. So I had to do the same thing. Yeah, and I think pretty much all that's just straightforward. Tick size, we did some math there to determine tick size. Pretty normal, I would say. And then, yeah, we also wrote the strings in there as well. The 0, 8, 16, 25. And that just corresponds to the steps and the max value given. Okay, so that's draw tick marks. I also have this draw number display, but you cannot see it at the moment because, and actually what it is, it's a number that appears right here. And you can't see it because of our clip path from earlier. There's probably a way to draw it on top. Yeah, actually, let me try that real quick. Okay, no, that didn't work. So the path really does take everything out. But if you wanted to include that, like I said earlier, you could change the clip path to just be the color of your background or something like that, which would then still remove the circle, but just paint it so that then the text will display. Just kind of a little workaround. The reason I did it this way is because I was experimenting because I thought that would be a little better. There were some issues when you're just painting a triangle in that sometimes if things adjusted in certain ways, you'd actually see part of the circle down here, things like that. So you got to be a little careful with that, but that just takes manipulation with however you're going to use it. Yeah, so I think the number display does look pretty good. I wish we could see it right now, but that's okay. And yeah, that's how we did the radial gauge. It was a lot of math, but you know, the good news is once you write it, you don't have to write it anymore. You just have to use it in apps later on. But I think it worked out pretty well. I would like to kind of spruce it up a little bit, make it look a little cleaner, maybe get a nicer looking needle, make it actually look like an odometer needle or something like that. Maybe change how the gradients work just to get that a little smoother, things like that. And fix this bug where it's removing this text here. But yeah, other than that, I think it's a pretty good example of what you can do with Maui.graphics. The idea would be you would create these once and then reuse them in various apps, depending on what you're wanting to do. You know, obviously there's use cases for radial gauges or like this linear meter. You know, if you're doing a weather app and whatever, you want a thermometer, you could restyle this to look more like a thermometer and use it in almost the exact same way. So pretty cool. Okay. And that's kind of it. I mean, I just wanted to show these, give you guys the code as examples and really walk you through it a little bit just to kind of help with looking at the code because it's not the most obvious stuff in the world. But if you enjoyed that, I hope you hit the like button, maybe even subscribe if you're so inclined. And yeah, we'll talk to you next time. Thanks. Bye.